So we have module 1. In module 1, we have 5 important questions. First is evolution of storage architecture. Second one is the core elements of data center. Third one, uh, third one is this is the third question. That is explain various factors of disk drive performance. Then you have disk service time. So all these factors you need to see, that is your seek time, your rotational latency, your data transfer rate, your IO controller, your utilization, everything you need to check. Then you have explain the components of disk drive. Your components being what is your platter, spindle, read write head, actuator, arm assembly, drive controller board, physical disk structure, and then what are the popular interface protocols between host and storage communication. So we know this module is about, the subject is about storage and how you share it between different areas and all. So you need to know basic of what is a storage to just write stories in this paper. What is storage? It is the data created by individuals or businesses that can be easily accessed for further processing. So that's why you need storage. And the what a device they are designed for storing the data is called a storage device or simply storage. So this device may vary from type to type and the rate at which it is created and used. Device such as memory in a cell phone and all those are storages only. So you have your first question, that is your evaluation of storage architecture. So they're asking, so what you have to write is, you know that there were mainframe computers which are present, right? And then now you needed large computers to store. Now you can store everything very easily. Like now here they've given tape reels and disk packets. You had pen drives, you have CDs. So all these are storage devices. And then this is used in their data center. Okay, this is for information storage. So what you're doing here is the evolution of open systems and affordability and ease of deployment they offered made them more convenient, and their servers and storages. So every business unit started having their own storages. So what you do is they have the approach of having an open system and storage was typically internal to the server. That is, every business started having their own servers. No, so that is server centric storage architecture. So what happens in server centric storage architecture is every server has limited number of storage devices and any number of administrative tasks, such as maintenance of the server and all increases storage capacity and might result in unavailability of information. So you need to rapidly increase the number of departments that they are being protected and unmanaged fragments, so that you make sure that all the data is available and stored in the particular place. So to overcome these problems of managing and all, you went from server centric to information centric architecture. So what happens here is, server centric architecture is you have different departments, and then all these different departments perform different tasks. So what you do in information centric is, you have different departments. You connect it to a storage network, and this network gives you storage devices. So under each device you can have any amount of data. All you can have 2 or 3 parts in this, which has part 1 department 1 information and department 3 information. You can have department 1 and 2, then 2 and 3, and then something like that. Okay, so you can have different combinations of information being present in the same storage device. So this information-centric storage devices are managed centrally, and they're independent of servers. So even if one server fails, you know you have the contents of the other server. That is what happens here. So the centrally managed devices are shared with multiple servers, and then this new server is deployed in an environment, and then the storage is assigned from the same shared storage device. That you have one common storage device, that is access to the for every device servers that is present. So the capacity of shared storage can be increased dynamically by adding more devices. So you, instead of having just one, you can just add more devices. You can add one more over here of six columns, and then you can have 8, and then you can keep on increasing. So in this is information management is easier and cost effective. The storage technology and architecture continues to evolve, which enables organizations. So they allow the organizations to protect, optimize, and leverage their data against the highest return of information. So main contents that you need to write is information centric to storage centric to information centric. That is where you moved, and then you have to write about how it was from mainframe. So we have this physical components of connectivity. That is, you have your host adapter, you have your cable, and you have your storage. Okay, these are the three components that are used. Uh, what is host is this is your interface device that gives you instruction like that it has to get the data from here and all. So that's your host adapter. So you have a host adapter bus. You have a host bus adapter that's called as HBA, and then you have a network interface card. Okay, that is your NIC. So it's like it asks for IO processing, and this mainly contains buses. Okay, and then a port is it's like an outlet. This is a special outlet that helps you connect between host and other devices. And then you have cable that is used. Your cable is it's an internal device, or it's made from either copper or optic fiber optics to send the media. You have something called as interface protocols that you need to answer for. So in interface protocols, what happens is these are the protocols that enable communication between host and storage. These are implemented on interface devices that are both source and destination. And then the main popular ones are you can remember FC and IP, that is fiber channel and internet protocol. Then SCSI, that is small computer system interface. For small computers, your system interface is being provided. And they have integrated device electronics, that is IDE, integrated device electronics or advanced technology attachment, ATA. Okay, so what happens here is you have a IDE, that is internet or integrated device electronics, or ATA, that is advanced technology attachment. So what happens here is that you're connecting it for storage devices like CD drivers and CD disk drivers and CD-ROMs. Okay, this is used in parallel transmission, also known as parallel ATA or simply ATA. Here this has a variety of standards and names. You can give that you have an ultra DMA 133 version of ATA that supports 133 MB per second of throughput. Okay, it happens in a master slave configuration, and you have an ATA interface that supports both storage devices per connector. It supports both storage. It supports two storages devices per connector. So you can use this master slave configuration to connect two devices. And then if performance of drive is important, sharing a port between if you want it to be very secure, you should not share, right? So that's what you're doing here. So your sharing is not advised if the performance of the driver is important. You have a serial version of this protocol known as serial ATA, and which supports single transmission. And then you have high performance and low cost SATA, that has replaced PATA in newer systems. Next we'll go to SCSI, that is small computer systems integrated, and serial for SCSI. So SCSI is it's emerged as a preferred connectivity protocol in high-end computers. What happens here is your performance and scalability and compatibility is better. Then you have higher cost associations limit, and it's popular among home and personal computers. Here what happens is you have 640 MB per second, which because of you can connect up to 16 devices in a single bus. Then you have your serially attached SCSI. That is your point-to-point serial protocol that provides alternate parallel SCSI. So this is transferable up to 6 gigabytes per second. And then you have your fiber channel. In fiber channel, what happens is it's widely used protocol. Here you have your interface provides a gigabit network speed, and then here it operates over copper or optic fiber, and the latest version is 16FC that allows 16 gigabits per second of transmission. Then you have your internet protocol. There's a network protocol, which is traditionally from host to host traffic. Uh, so what happens here is your IP network has become a viable option for host to storage communication. IP offers several advantages. That's cost, maturity, and enables organizations. And then you have ISCSI and then FCIP protocols that are common leverage for IP host to host communication. For storage, we have this is the core of your data centers. Okay, what happens is it uses magnetic, optic, or solid state media. You have disks, tapes, and then disklets to use magnetic media. You have CD drivers to use optical media, and then you remove flashable memory. That is your pen drives. Okay. And then you have tapes. In the past, tapes have been the most popular storage options for backup because of their low cost. So now tapes are limited due to random access is very slow and time consuming. So you cannot linear. You have to search it in the linear length. So you have this device, and then your tape goes around this, right? So it has to be linearly searched. So and then you have multiple applications cannot be accessed simultaneously, so you cannot share the computing environment. Then you have tape drive. The reading or writing head touches the tape surface, so the tape degrades and wears out after repeated usage. Okay, and then you have storage and retrieval requirements from the tape, and the overhead association with managing the tape media are significant. Due to this ability and due to this limitations and ability of low cost disk drivers, tapes are no longer used for right now stage. So you have optic disk storage. What is this? Is it's a small single user computing environment, and then you have it is frequently used by individuals to store photos and then backup memories or laptops and computers. Then you have this your your optical discs also use it's used for small applications such as games or transferable media from one system to another. This is write once and read many times. It's a CD. Okay, you have a CD-ROM, and then you write once, and then you can it can be read multiple times, right? You play it, you download songs, and then you write it into it, and then you can play it multiple times. And then you have collections of optical discs in an array called jukebox. Okay, jukebox, and then this is used as a fixed content storage solution. Other forms of optical discs are CD read write, Blu-ray discs, and other variations of DVDs. And then you have disk drivers. These are the most popular storage medium that is used for modern computers. Here, what happens is you can have repeated access to random locations. These have large capacities. You can have increased capacity, enhanced performance. So these disk drivers are accessed through predefined protocols such as ATA, SATA, SAS, and FC. These protocols are implemented on the disk interface controllers. So this disk interface controllers were earlier implemented in separate cards, which are connected to the motherboard. So what happens here is your modern disk interface controllers are integrated with disk drivers, and therefore the disk drivers are known by the protocol interface they support, that is SATA disk or FC disk, etc. So this will be part 1, and for part 2 I'll do everything related to disk drivers, that is your disk driver variations related to disk driver performance, and then components of disk driver, and then even the one of processing a mapping user file to disk storage.